Hi everyone, what you can see here is a quick mock-up I did in SketchUp of essentially a porch I was going to put on the workshop door, and also it would double up as a spray booth so I could get on and start doing the lacquer on the double neck guitar project. Unfortunately, since November this is pretty much what we've had, and the rain has essentially stopped me from building this thing, and to be quite honest, it's probably pretty much stopped anything happening outside for the last couple of months. So I was looking for another project to do, or at least start. The cockpit project's on hold because I'm waiting for the force sensor modification for the joystick, and also the monitors, which won't be here this side of Christmas. And a friend of mine also has only an acoustic guitar and could do with an electric, so I fancy making one for him as a gift, if you like. And also you can never have too many guitars yourself, and recently I've kind of taken a liking to the Fender Jaguar, which has always been a bit of the forgotten stepchild, if you like, of the Fender family. And but having played one recently in a guitar shop locally, I really liked it, especially the neck pickup. I think it's actually the rhythm circuit on there. It's an interesting guitar. It's fairly unique as well with its 24-inch scale length. So scouting around on the internet, I found this PDF set of plans for the guitar. Now, some of the bits on here, after doing a bit of research, need some modification. This is not the correct routing, I believe, for the pickups, but that can be remedied. In fact, I have another plan showing the Jag pickup routing, excuse me, but the rest of it seems to be okay. It's supposed to be a 62, not sure if that's correct or not, given the headstock shape. Maybe somebody who's more knowledgeable in these things can help me decide. So anyway, I thought I'd have a crack at this, and as with any guitar, really most of the work, especially on a Fender, due to its the way they're designed and constructed, is essentially for mass production, and most of the work actually goes on the neck. So I thought I'd have a go at doing the neck on CNC, mainly because although I could probably do one by hand, I'm not that confident about it. My woodworking skills, whilst not too bad, are kind of limited mostly to kind of joinery and stuff. So maybe I'll pluck up courage sometime in the future, but for now I figured, well, I can turn these things out in the neck out in CNC, and also it gives me a really interesting project to do in Fusion 360, which will kind of stretch my abilities within the CAD and CAM side of Fusion 360, but also in the learning the intricacies, if you like, of the software, because there's nothing like a complex shape to drive out and identify where the oddities, if you like, and challenges are in a piece of software. So anyway, first thing I had to do was get this PDF into Fusion 360 itself. Now, Fusion 360 is quite strange. It has essentially the ability to upload files to the cloud, where it then performs essentially a conversion, if you like. I assume it's done on their side, on their compute side, within their data center or whatever, and then gives you the results back as a sketch. But of course, first what I had to do was get this thing converted into a format which Fusion 360 could convert from itself, and I don't think it does PDFs. If somebody knows whether it does or not, let me know. But anyway, there's far too much detail on these diagrams, which are probably great if you're building one from scratch. So as luck would have it, my older that was it, Cut 2D CAM package can import PDFs, and what's more, it can also export DWF, I think it is, files, or DWG files. Can't remember which one it is now. One of the vector 2D CAD drawing files. So basically, I loaded this into Cut 2D and stripped away pretty much everything apart from the neck, and the details showing there. So what I did, if I just zoom in here, hopefully this shows up nicely. This is the first time I've also used OBS for screen capture, so you'll have to excuse me while I try to get on with this piece of software as well for the first time. Okay, so what we got here is I needed this neck piece here, so we needed to get rid of all the strings. We don't need to show the tuning machine, so that all went. All this labeling went as well. I kept the frets in, and I also kept the dot markers, the nut slot here. Hopefully you guys can see me doing this on screen with the mouse cursor there, and I also kept these profile sections here, even though it says 1 to 50, so that actually they're now if you print this out 1:1 scale from the PDF, it actually comes out life size. I checked various measurements of the micrometer, it's actually pretty accurate. So these are actually twice the size that they need to be. Now I'm assuming, or I assumed, that this section here, the smaller one, the smaller neck profile here, is at the nut, and the larger one is here. I think it is. It's one of these frets. I can't remember which one now, but one of these frets I found out must be this one here, which is just before this triangular dotted lines section, which shows you where the profile blend starts on the back of the neck. So what I did is transferred the remainder, if you like, or the outline that I thought I needed, over to Fusion 360. Now the other important piece on here was essentially the thicknesses of the neck, which I could take at various points as well to help me out, and the thickness of the headstock, and also what the profile looks like for the blend transition, if you like, from the headstock into the neck profile itself. So let me just flick over to Fusion 360, and I'll show you some of the workflow over there. Oh, probably worth pointing out as well, very usefully, the this set of plans also has to a very pretty good degree of accuracy the fret distance from the nut, and also the distance from each, or the spacing, if you like, between each fret, which is extremely useful, especially for the Fender Jag, because having a 24-inch neck, that's not going to match up with either a Gibson or the Strat Telecaster scale lengths. So that was also extremely useful. Right, so let me just flick over to Fusion 360, bear with me. Okay, so we're in Fusion 360. Unfortunately, the tree doesn't show up in this area on OBS for some reason. It's probably a setting I've got, but we'll try to make do without it. Anyway, this is essentially the sketch, if you like, or what was brought over from the Cut 2D import and export. Okay, so what we got was this. Now this is actually cleaned up as well. I deleted a bunch of vectors that I didn't feel I needed, and as I went through Fusion 360, now Fusion 360 uses essentially two main modeling constructs. Trying to think of the right word for that. So it uses 2D sketches, which you can sketch in pretty much any plane you like, and then it can extrude those, if you like, into solid models, or bodies as they call them, and you can do components, and you can also, and the good thing about that is you can take a 2D plan like this and turn it into a 3D model. So first thing I did is I extruded the outline of the neck to get this, and also did the headstock as well. Put a face on it so that it's kind of enclosed, and turn that into a solid. Now also, when I extruded, all the other lines also got extruded with it, which was somewhat annoying because I don't really need those, you know, extruded from the original diagram. Let me just activate all of these, and you can see what it looked like when I first extruded the model. It looked like that. So everything got extruded out, every vector, if you like, on that sketch got extruded out. Let me just bring the sketch back up. You can see the sketch behind it there. Now I extruded this section, the neck section, out. I think it's 21mm, which matches the cross section on the plan, and extruded the headstock out 14mm, which also matches the headstock on the plan. And although the good thing is the holes came with it, so that was pretty good news. But there was a lot of cleaning up needed, so I had to essentially switch off all this weirdness that I didn't need, all these compartments, just so that I had essentially an outline. So we ended up with an outline shape for the actual neck. Now I kind of approach this from the point of view, you know, as if you were doing this from a kind of routing perspective. So you take your neck blank and you'd route this section out, and probably the headstock all at the same thickness of 21mm once you planed it down to that, and then you'd probably route this section down to the 14mm, and then you'd start working on your transitions and other details. So anyway, this got me to, let's just get that in view properly for you guys. So this got me to this stage. Now I then turned that into, let's see if I can get the right model up. Yeah, okay, so what I then did with the sketches is I then got a sketch up essentially for the face of the model again, which is the same sketch, you know, it's the same plane there, and you can see in the middle here I sketched out the truss rod slot and the wider part at the end here. Hopefully you can see that on there, which is where the truss rod nut is. So and then did essentially a cut extrude from this sketch into this body. Now the other thing I needed to do, and I'll have to see if I can get them up, here we go. You see that sketch there and that sketch there are the two profiles that I showed on the PDF plan earlier. Put them in the right place, they match up with the frets that they're supposed to be. So actually it was the first fret and I think the 12th fret, and essentially did I think it's, yes, the loft. So you can take something like this sketch here and loft it over to this sketch, and what it does is it creates it does its best to try and blend, if you like, one shape to the next one as a solid body. And what that came up with, if I flick this sketch off and this sketch off, is take that out. I'll spin this over or spin it round. You can see that what it did, and then once it created that, I did a intersect, if you like, with the block body, and that got me the back of the neck profile here. So we're now looking fairly good. The other piece that we needed to do was this transition piece here. Now that was fairly easy actually. What I did is just create a circle, an arc rather, and I might have the sketch still on here. Let's see if we have, yeah, there it is. See this line here. Oh, there it is. Yeah, so that line there, and essentially extruded that up to a plane, intersected it with the neck at that point, and then deleted, if you like, the stuff above this transition, which left me this shape. Now the next bit took me ages to do. So if we spin round, and probably the most complicated part on this is the transition from, let's just bring up the import piece here. So this piece is fairly easy because that stays flat essentially. We've got our hole markings there as well if I wanted to pre-drill those, and again this bit is fairly easy once you've got it drawn, which is that piece. It's these transitions here, and it took me ages to try and find a way of doing it. And what I ended up doing was deleting out this section of the model here. Let me see if I can show you that with me. I'm just going to have to flick over to another model. I did a lot of save as on here to keep various versions of the model intact, so that I could essentially roll back, even though Fusion 360 does actually keep pretty good version control actually. Yes, so if you can see that one there, so that was taking that sketch there. So what I did is create essentially a block here. Let me bring that one up if I can. Right, so bring that one there and this one here, so you can see here, look, on this bit here where I essentially cut the model at that point. So what you actually ended up with, you can see that very easily. There you go. See where the neck body is essentially isolated. So I had a neck body, I had the headstock and the heel, and what I needed to do was blend this to this shape, and I tried all kinds of stuff. So I tried the sculpt T-spline thing that features that Fusion 360 comes with, but I just couldn't get that to match on either end of the neck. So that's on, you know, on this transition here. or this transition here. Couldn't get them to work. In the end, what I ended up doing, and it was quite weird, and I found it almost by accident, which I guess is how most good things happen. If I took the face, if you like, of this body here, and I lofted it across to, and I'll just bring that here, lofted it across to this face here. You can see me pointing with the cursor, hopefully. What it ended up doing was creating the right profile shape. In fact, it was almost exactly what I was looking for. So, but I had to do a few kind of cutaways, if you like, or a few cutaways and a few joins essentially to get it to work properly. But in the end it did, and you can see I got the heel transition. Let me see if I can, there we go, we can highlight that, and that worked okay, although there was some patching up to do on the truss rod slot. In fact, what I did is I filled in the truss rod slot again and redid that from scratch. And the neck transition almost did it, but I just couldn't. If I just bring the neck transition up, I couldn't get this concave kind of compound curve blend that occurs in this area. Oh, hang on, it's just there we go. Couldn't get that compound curve that occurs in this area here, or in this area underneath. Let me just spin that over. So this bit here, you've got kind of a cliff face, but I guess the good thing was that you know, this is more material than's actually required. So essentially I could use the spindle sander. I can use my spindle sander, if you like, to profile this piece in manually, and it's I guess 70-80% there. It just needs essentially a tidy up. You can also see that this piece here to there is essentially a straight line, and that should actually be concave. So there'll be a bit of work to do, but in general it's pretty good. Now, the other thing I did, which is an interesting thing to note, is I took, and I'm going to flick models again here. No, that's the truss rod sketch. Ah, there we go. Right. What I did is I got all the fret slots and isolated. You can see what I had to do is create essentially boxes, and also create an offset version of the fretboard itself on the sketch with an offset with 1.5 millimeters off. Let me just move this round to the front so we can see it in plan form. There you go. So there's a 1.5 millimeter offset there, which basically means that will be the binding. And the fret slots themselves, as you can see, are 0.5 millimeter wide, and we've got a 6, I think it's a 6 mil 6 mil dot inlays, so, or at least the holes for them. So what we did is we can turn that a block like this, and now I had to take 2 goes at this, and I'll explain why. So the first time I created a cylinder, got it to join up along the midpoint there, or touch at the midpoint at either end of the fretboard. This won't be a compound radius, although I guess I could do by making that cylinder a cone if I wanted to. And what we did then was essentially use this cylinder and this cylinder I went for a 9.5 inch radius fretboard because that matches, rather than the 7.25 on the original instrument, because that matches essentially my Strat and Telecaster, and I'm quite comfortable with that radius fretboard. So what I did is use this to cut. Now I did this twice, because the first time, being an absolute plank, I made this cylinder 9.5 inches in diameter rather than radius. So the thing was far more curved than it should have been. But essentially you cut the fretboard as a flat block, if you like, and use it to split it, and then what that gives you is a fingerboard negative, which I can probably use to make a call or something if I need, or a radius block, and then that leaves you with this finished fingerboard here. So, and then really it's just a case of doing an extrude cut for the inlay holes, similarly with the fret slots as well, and excuse me, and then also the nut slot here. Now I did this before I did the headstock transition, and therefore that intersect, because it was, if I bring the neck up, there we go, and ignore the weirdo texture, makes it look a bit funky, I'm afraid, but in essence you can see that profile there, you can just cut that whole piece away. It's almost as if you had a virtual spindle sander and you just run it into the transition between the two. So gave it a bit of colouring there just to and we got our blue background back, there we go, that's nice. Yeah, so it was quite a long task to model, and I would say that the hardest part, I mean the fingerboard actually didn't take me that long at all, probably about an hour, but it took me days to work out how to get this transition here for the heel, and especially this one, and it's still not there. There's probably a way you can do this. I've tried manually kind of pulling various vectors, you know, facets that exist on that part of the model, and nothing I do seems to work, so I can live with it basically. But as you can see, we've now got essentially our model. Not only that, we've also got a rebate here ready to go for the binding, so we don't even have to, you know, manually route that, providing I could machine everything. Let me just see if I can get this. There we go. And there we go. Providing I can get the tool paths okay, then we should be good for machining. So I head over to the cam part now and get rid of the fingerboard for the moment, because we'll concentrate on the actual neck itself. So that'll be the first part, made out of maple, as is correct. And what I did is I created a block, stock material. You can see here the 0 point is a bit funny, but actually it works out okay in the end, as you'll see later in this series when we get over to the CNC machine. So the first thing we need to do is, because I was going to test this, I got some 18mm ply, so 2 sheets of that stuck together essentially makes a 36mm block of wood. and we need to face that down so that it's up to the point of the face of the material here, so, or the top of the neck or the front of the neck, sorry. So we did just a facing pass, which is just a 2D operation, and if I click that you can see that there, and basically it's just it goes back, it uses climb milling. I think I'm using an 11mm 4-flute cutter just to get rid of material as quickly as possible. Not too fussed about you know, how good it looks, providing the bottom surface rather, or the surface which will be the top of the neck or the front of the neck, isn't too rough. So that's that toolpath. Then I did an adaptive roughing, which is pretty much my favourite tool strategy these days. It's absolutely superb, as you've seen in the aluminium, and that gets us essentially further down. I think I was using a 5mm step down, but also you can see these cutting parts here where it's roughing out the transition and leaving stock material there to take off later on the transition from the headstock to the actual neck front. So that just takes this down to the dimension, and I think I left 0.1mm stock material on the face just so I got something to sand afterwards. So then we go down again. Let me just and then we just use a standard boring toolpath which just spirals into the stock and then runs around the hole to take, I think it's 0.2 of a mil off the inside as a finishing pass, all in one operation. So it does all 6 tuning machine holes, which is good news. That's just using a 6mm single flute cutter. Oh, sorry, the headstock, this one's using an 8mm 2-flute cutter. Then we've got headstock finishing, which is a 6mm ball nose, and you can see there's a high concentration. Oh, that's gone again. There we go. Let's see if we can get. You can see there's a high concentration of blue lines there. That's just where it's doing loads of passes, essentially to make sure it's got a nice smooth finish. It's a bit strange why that won't show the cursor occasionally. Anyway, that's for that area there. Then we move on to a 4mm single flute end mill, and what that does is it does the main truss rod slot. There's a bit of air cutting here, probably I could get rid of that somehow, but that's not too much of an issue, and that makes the main truss rod slot. And then we use another one here which is using a 3mm ball nose cutter, because we want a concave, you know, semicircular profile. Just, yeah, so you want this arc here, if you see that. So we use a ball nose cutter to get that. A bit of a strange strategy. In fact, I used adaptive in the end because it seemed to be the only one that could get that tool into that part of the model, and it was more to do with trying to select. And this is something that I find a bit irritating with Fusion 360, and it's probably the way I've modeled it, is because this model is made up of a lot of different sections where I had to do all the intersects and stuff like that in order to make the model in the first place. It's probably not as simple as it should be, and therefore it makes it very difficult to actually select faces and profiles on the model, which is a bit of a shame. Right, the other thing we needed to do, now I did model 4 holes in here, but in the end I've abandoned these. You can see these 4 holes. You've got one there, one over here and one over here. Now this was so that I could flip the part over and maintain 0. Then I realized, of course, that wouldn't work, so I don't actually use those. What I do is I use a 3.2mm hole right under the 0 marker here, and then another one down in this area here, so that we can flip the model over in the x-axis. Let me see if I can get that. Do that. So, no, that didn't work. It's flipping it the wrong way. Sometimes the controls on this software are a bit funky when you're trying to look at various things. Anyway, you can flip it over, and then we can machine the back. So I didn't do the locating holes, and although I did kind of pre-drill a hole here for the string tree, I figured I could do that manually anyway later on. What I did do though is I did do a quick pass with the an 8mm 2-flute cutter for the binding rebate, although there isn't actually that much of a rebate there. I think that's about 0.4 of a mil, if that. But so long as the fingerboard is there, we can glue that on there, and then we can get the binding on. Now, that's essentially most of the shaping, if you like, tool paths on the neck. And then what we needed to do was do a cutout, and for the life of me I could not get the thing to profile around the edge of this model. So what I had to do was get the sketch, create a new body which matched the sketch outline of the entire neck. You remember the one right at the beginning where I extruded out to make the kind of block body to start sculpting away in the CAD, and then that I could select that and then use that to cut out the profile shape here, look, and that essentially should give us the part free and all the operations on this side. Then what's needed is we need to flip it over, and you need to create a new set of operations for this. Okay, so we flip the part over on the machine, and then we use a roughing toolpath. Now remember, we haven't got all the stock material because we've freed the neck essentially from the block it comes from. Not quite sure what's going on in this area here, but never mind. If it's going to be cutting air, at least it's not cutting something it shouldn't be. So that, and just in case there is any extra stock left on the back, I'm basically taking any extra stock on the back down to this level, and I can't for some reason, so this level on the heel and this level on the back of the headstock, before it then goes in to rough out essentially the profile on the back here. And then there's a parallel finish where the tool basically just goes backwards and forwards with the 6mm bullnose cutter and smooths the whole thing out, and then you get your neck profile. At least that's the theory. Now what we can do on here, what we can do hopefully is we can simulate this, and I'm going to just put this piece of stock, rewind the thing, and then we're going to play that, and I'll speed this up so we can simulate how it goes. You can see the tool, this is sped up massively. If only my machine could remove the material this quickly. So we face down to the I think it's 21mm it needs. Then we go in and you can see the adaptive toolpath, essentially cutting out the headstock. We then, so that's the roughing pass, there's 2 layers to that, look. Then we stick in the tuning machine holes. Then you can see it here, it's now doing the finishing toolpath, and we'll speed that up. It seems to be slow and very fast to blend in the transition between the headstock and the front of the neck. Then we're doing the neck slot then we do the end, then we do the binding rebate, or what there is of it, and then we proceed to cut out. So do the cut out, and that will cut the neck out. Oh, and it's already started on the other side, bear with me. Let me just pause that, and we'll just start that off again. And basically it starts roughing out the back of the neck, so I'll speed that up, taking down whatever material's left, and see it's facing off. It's just if there's anything left, and there shouldn't be, and then it's working its way down either side of the neck, doing a roughing toolpath, just to start the profile off, and then we should go into the parallel operation, and there you go, you see it's finishing off the back of the neck, and that should be, I suspect this is OBS. Oh, there we go, that's doing it, and that should be the neck. I won't show the fingerboard just yet, because what we'll do in the next video, and this video's probably gone on long enough, is in the next video we'll move over to the CNC machine and run the test essentially in plywood. I don't want to be testing feeds and speeds in relatively expensive maple, especially as some of these tool paths have got some oddities and things that I've never tried before. So we'll go over to the CNC machine in the next video. Should be up in a day or two, because I've actually done it, and you can see how I got on the actual machine cutting a neck out. Okay, so I mean that's the CAD and CAM side of this. So hopefully join me in the next video when we can get on with the actual CNC work. And thanks for watching as ever. Thanks.